This is Module 4, P-Link Module Installation. We're going to start with the two cards that enable the system to be wired Class A, the CA6075 and the CA6500. These cards provide the return terminals for the P-Link, the SLC, and the 2 or 6 built-in notification circuits depending on the panel. We're going to start by looking at the installation of the CA6075. On the PFC-6000, 6075 and 6030, the CA6075 Class A card gets installed just to the right of the keypad as indicated here by the yellow rectangle. I'm going to zoom into that location so that you can see up close where this card gets installed. The CA6075 comes with a bracket. The card must be removed from the bracket and then bracket installed first. Remove the two screws as indicated here by the yellow rectangles. The bracket will rest in these two areas indicated by the other two rectangles and will secure by the two screws that you removed. As you can see in this picture, the bracket is now installed. The CA6075 card will now plug in to the plug in the back of the board as indicated here by the yellow rectangle. You can see in this picture the card is now installed and it is secured by two screws. You can see that it is now providing the return terminals for the SLC, the P-Link, and the two notification appliance circuits. When wiring Class A, you would leave the main board to say a notification circuit and then return back to the NAC1 terminals provided by the CA6075 card. The same is true for the P-Link as well as the SLC. As mentioned in the previous module, these things are configured independently through the software, which means that you can set it up such that just the SLC is Class A, or just the P-Link is Class A, or just the notification circuits are Class A. It is configured to whatever application you need. The CA6500 installs behind the motherboard. There is a slot for it and it will slide right into place. It is secured by two screws on the bottom and it plugs into the main board as shown here by the red rectangle. For further installation instructions, please refer to the installation manual. The UD1000 provides the ability for the panel to communicate to Central Station via phone lines. It's a two-phone line dialer. It communicates contact ID and SIA, it has built-in line seizure, and it does allow for remote upload and download without the need of a special modem. For all of the PFC-6000 series panels, the UD1000 installs behind the keypad. Prior to installing the card, make sure the dip switch on the front of the card is set to 1. It should come factory default set to 1, but if it is set to 0, the Fire panel will never see the card. There are grooves in the bracket that the UD1000 will slide up in order to install behind the keypad. As you can see in this picture, it will slide up behind the keypad and then it will secure by one screw. It will connect to the panel via the red and black cable that you see here, either to a terminal labeled P5 or P4 depending on the panel. Once installed, you can easily access the two phone line jacks at the top of the card. You'll notice that line 1 is on the right and line 2 is on the left. The jacks on the card are RJ11 connections. The card does come with a cable that goes RJ11 to RJ31 for easy installation in the field. On the bottom of the card there are LED indicators for line 1 and line 2 as well as a COM indicator. The COM LED indicates communication between the Fire panel and the dialer. The LEDs for line 1 and line 2 indicate the traffic going over the phone lines. These LEDs are very useful in troubleshooting if you've forgotten your bud set. For more information on the installation of the UD1000, please refer to the installation manual. For programming information, please refer to the programming module. Moving now to the remote LCD enunciators, the RA6075 and the RA6500. Both of these remote enunciators can be used on any of the PFC-6000 series panels. The keypad functionality at the remote enunciators is the same as at the fire alarm control panel. You can install up to 31 remote LCD enunciators on any of the PFC-6000 series panels, any combination of the RA6075 and the RA6500 totaling no more than 31 devices. We're going to be looking at the RA6075 and how it installs. It is identical to the RA6500. The remote enunciator is keyed the same as the Fire panel. When you open the door, there are two screws that attach the keypad to the back box. Remove those screws and the keypad will come out. You'll notice that the back of the annunciator is pre-drilled for installation on a single gang or 4-square back box. There is also a conduit knockout in the middle back and on the bottom of the back box. On the back of the annunciator you will find 4 terminals for your P-link labeled A, B, plus and minus. You'll also find a dip switch for setting the address between 1 and 31. Bring your P-link wiring into the terminals, and if you need to go on to another P-link device, continue on with that wire under that same terminal. For more information, please refer to the installation manual. The LED annunciator, the LED-16, has 16 zones. Each zone has an alarm, supervisory, and trouble LED. You can have a maximum of 31 LED-16s on the PFC-6000, and you can have a maximum of 10 LED-16s on the PFC-6200, the PFC-6075, and the PFC-6030. The back box for the LED-16 is identical to the RA-6500. It is keyed the same as the fire panel, it has the same conduit knockouts, and the same pre-drilled holes for mounting. There is a dip switch on the back of the LED-16 for setting the address. This device needs an address between 1 and 31. Looking at the terminals on the back of the LED-16, you'll notice there are 2 extra terminals besides the 4 P-link terminals. Those terminals are for auxiliary 24-volt power. A P-link circuit from a fire alarm control panel or the PSN-1000 has 1 amp of power available. The LED power auxiliary terminals are provided so that you can install the maximum number of P-link devices without draining the power off the P-link circuit. When wiring the device, bring your P-link wiring into the terminals, keeping your polarity straight, and if you need to go on to another P-link device, continue on with that wire under the same terminal. Providing auxiliary 24-volt power is optional. If you do not want to provide auxiliary 24-volt power, jumper the LED power terminals to the positive and minus terminals of the P-link connection as shown here. If you will be installing an auxiliary power supply for the LED power, make your connections as shown here. These terminals are fully supervised to monitor the 24-volt power coming in from your auxiliary power source. The LED annunciator also comes with blank zone label cards to label each zone. The cards fit into a slot behind the front of the annunciator. Remove the label and each zone has a spot for identification. Once you have your labels filled in, return them to the slot and your labels are easily seen on the front of the LED-16. For more information on the LED-16, please refer to the installation manual. Moving now to the P-link accessory cards. These cards come mounted on a bracket. These brackets can be stacked. In most locations, they stack 3 high. They are referred to as stacker brackets. Stacker brackets can be mounted in the following cabinets. A total of 6 can be mounted in the 6800 and the 6200. A total of 6 can be mounted in the PSN-1000E. A total of 14 can be mounted in the AE-14, and a total of 8 can be mounted in the AE-8. In each cabinet there are standoffs that the first bracket will attach to. This picture shows the 6800, the 6200, and the 1000E. Each one has 1 stacker bracket in it. There is still room for 18 amp hour batteries to be installed underneath the bracket. We're going to start with the SLCE-127. This card allows you to add an additional 127 addressable points to the PFC-6200 and the PFC-6800. 1 SLCE can be installed on the PFC-6200, giving it a total of 254 points, and 7 can be installed on the PFC-6800, giving it a total of 1,016 points. Looking at the terminals on the card, you can see the P-link is in the lower left-hand corner. You bring the P-link connection in, and if you go on to another device, you can go off those same terminals. There is a dip switch on the card for setting the address. These cards can get any address between 1 and 31. When connecting to the devices in the field, use the terminals that are labeled SLC out. If your system is required to be wired Class A, the return terminals for a Class A circuit are provided on this card. They are labeled SLC return. Don't forget to program the card in the software as a Class A card. Looking next at the DRV50, the DRV50 provides 50 user-configured LED outputs. It provides 6 system LED outputs. It has 4 supervised dry contact inputs that are programmable by the user. A maximum of 31 DRV50s can be installed on the PFC-6000 and a maximum of 10 DRV50s can be installed on the PFC-6200, the PFC-6075, and the PFC-6030. Looking closer at the DRV50 card, the 50 programmable LEDs are located on connectors P1 through P5, each containing 10 LED outputs and 2 5-volt outputs. The system LEDs are located on connector P6. The LEDs are wired as shown here. No external resistor is required. All outputs are power limited. All connections to P1 through P6 are limited to same room installations. The 4 programmable dry contact inputs are located on connector P7. All the input circuits are power limited and use a 5.1K end-of-line resistor. The inputs can be programmed for any of the contact input functions similar to an MCM, SCM, or DCM. Those input functions are found in the software. Looking now at the terminals for the P-Link, you'll notice there are 2 extra terminals labeled LED power next to the P-Link connection. The higher current required for the LED outputs can be provided by the panel via the P-Link or an auxiliary power source wired into the LED power terminals. We'll start with the P-Link. Bring the P-Link wiring into the terminals, keeping your polarity straight. If you need to go on to another P-Link device, continue on with that wire under the same terminals. Providing auxiliary 24-volt power is optional. If you do not want to provide auxiliary 24-volt power, jumper the LED power terminals to the positive and minus terminals of the P-Link connections as shown here. If you will be providing auxiliary power, wire that to the LED power terminals as shown here. There is a dip switch for setting the address of the DRV50. The DRV50 needs an address between 1 and 31. For information on programming the DRV50, please refer to the programming modules. Next we move to the RLY5. The RLY5 provides 5 user-configured relays. The relays are each rated 3 amps at 24 volts and 125 volts. You can have a maximum of 31 RLY5s per panel. Taking a look at the terminals on the board, you can see the 5 relays are located on the top of the board. They are wired as shown in this diagram. Looking now at the terminals in the lower left-hand corner, you'll notice there are 2 extra terminals located next to the P-Link connection labeled RLY power. The RLY5 higher current required for the relay outputs can be provided by the panel via the P-Link or through an auxiliary power source. That auxiliary power source can be any 24-volt source, and it is fully supervised. Looking first at how the P-Link is connected, bring your P-Link wiring into the terminals, keeping your polarity straight. And if you need to go on to the next P-Link device, continue on with the wire under the same terminals. Providing auxiliary 24-volt power is optional. If you do not want to provide auxiliary 24-volt power, jumper the RLY powered terminals to the plus and minus terminals of the P-Link connection as shown here. If you will be providing auxiliary power, make that connection as shown here. There is a dip switch next to the P-Link terminals for setting the address of the RLY5. This card can have any address between 1 and 31. For information on programming the RLY5, please refer to the recorded module. The next 3 cards that we are going to be talking about, the FCB-1000, the FIB-1000, and the SPG-1000, all have the ability to be mounted in a 19-inch rack mount. This is an optional mount. This picture shows you what that looks like. We're going to start by looking at the FCB-1000. All of the PFC-6000 series fire alarm control panels support one FCB-1000. This card provides an optional remote network connection for IP reporting to a central station. This card is fully supervised by the fire alarm control panel and is UL 864 compliant. This card can mount in the PFC-6000, 6200, and the PSN-1000, as well as the expansion cabinets. It can also be mounted in a 19-inch rack mount. That mount is optional, and that part number is an FCB-1000RM. Looking at the card a little closer, you can see the P-Link connection is in the lower left-hand corner. Like the previous cards, bring the P-Link wiring into the terminals, keeping your polarity straight, and if you need to go on to another P-Link device, continue with that wire under the same terminals. There's a dip switch for setting the address of the device. This needs to be set to 1. You can see the Ethernet connection is in the upper right-hand corner. In order to comply with UL 864, the IP connection for IP reporting to a central station needs to be in the same room as the connection to the network equipment. This connection shall be limited to 20 feet and enclosed in conduit, or equivalently protected against mechanical injury. Next, we will look at the FIB-1000. This is the Fiber Interface Bridge. This card enables the 4-wire P-Link bus to be converted to fiber optic cable and from fiber optic cable. The fiber can be wired in a Class B or A configuration, and this uses multi-mode fiber optic cable. This card can be mounted in a 19-inch rack mount, and that part number is an FIB-1000RM. It can also be mounted in the PFC-6000, the PF-6200, and the PSN-1000E cabinets, as well as the accessory cabinets. You can have a maximum of 30 FIB-1000s per panel. They need to be installed in pairs. Looking at the FIB-1000 card, you'll see there are terminals for the P-Link connection. There are also fiber connection terminals at the top, and there are 2 dip switches that you can see here. Dip switch S1 is for setting the address of the FIB-1000. These cards need an address between 1 and 31. Because the FIB-1000s are installed in pairs, they are addressed consecutively. For example, if you give the first one address 1, the next one will have to be address 2. Switch S2 is set to differentiate the first FIB-1000 from the second FIB-1000. The first FIB-1000 converts the copper P-Link to fiber, while the second FIB-1000 converts the fiber back to copper P-Link connection. Set S2 on the first FIB-1000 to the off position, both dip switches in the down position. Set S2 on the second FIB-1000 to the on position, both dip switches in the up position. Looking now at the FIB-1000 wiring. Here I am showing the FIB-1000 installed in a PFC-6000 can. The first FIB-1000 can be installed in the PFC-6000, the PFC-6200, the PSN-1000E, the AE expansion cabinets, or the FIB-1000RM rack mount. Just as an example, we have it here mounted in the PFC-6000. Taking a closer look at that picture, you can see the P-Link from the fire alarm control panel is wired into the P-Link terminals of the FIB-1000. This is shown in a Class B configuration, and in that case the fiber connectors are connected to RX1 and TX1 going out to the next FIB-1000. The second FIB-1000 card needs to be mounted in a PSN-1000E. The distance between the first FIB-1000 and the second FIB-1000 is determined by the amount of signal loss on the fiber. This fiber is multi-mode fiber, and it tolerates up to 12 decibels of signal loss. Looking closer at the wiring of the second FIB-1000, you'll notice that the incoming fiber is connected to RX1 and TX1. The P-Link connection on this FIB-1000 is connected to the P-Link connection on the PSN-1000E. Because this is the start of this P-Link, that connection has no power, and in order to power that P-Link connection, we need to bring power from the isolated P-Link repeater that is just to the left of that. You will see there is a jumper between the positive and minus of the isolated P-Link to the P-Link connection that our FIB-1000 is connected to. We can now use the isolated P-Link connection on the PSN-1000E to connect to the P-Link devices in the field. We have 1 amp of power and 6,500 feet available on this P-Link connection. Remember to set the dip switch of S2 to the on position on the second FIB-1000. For more information on the wiring and programming of the FIB-1000, please refer to the installation manual and the other pre-recorded modules. Moving now to the SPG-1000, this card provides a serial parallel printer interface. It is fully supervised and supports real-time event logging. This can be mounted in the PFC-6000, the PFC-6200, the expansion cabinets, the PSN-1000E, as well as in the 19-inch rack mount, and that part number is an SPG-1000RM. You can have a maximum of 31 SPG-1000s per panel. When wiring the SPG-1000, you bring the P-Link connection in from the previous P-Link device or the fire alarm control panel, and then if you need to go on to another P-Link device, you take the wire under the same terminals to the next P-Link device. The dip switch on the SPG-1000 is for setting the address. This card needs an address between 1 and 31. You can see on this card the connectors for the serial connection as well as the parallel connection to a printer in the field. This serial parallel printer connection is limited to same room installation. This connection shall be limited to 20 feet and enclosed in conduit or equivalently protected against mechanical injury. For programming information on the SPG-1000, please refer to the recorded module on the SPG-1000 programming. For more information on the SPG-1000, please refer to the installation manual. The next video in the series is Module 5, SLC Devices. For more information on Potter products, please visit our website at www.pottersignal.com. And please let us know if you have any questions by dialing 1-800-325-3936.